In this video, I'm going to talk about substitution, which is one of the methods we will be using when we're doing systems of equations. We already looked at what a system of equation is, and we looked at how you would graphically solve the system of equations. And the last two methods we're going to look at before word problems are substitution and something called elimination with addition. And these are algebraic ways of solving a system of equations. Now, substitution is useful when you have a variable that is isolated in one of the equations. And if there isn't a variable that's isolated, it's helpful if there is a coefficient of 1 somewhere. So what I mean by that is coefficient is the number in front of the variable. This is a -3, not a 1. This is a 4. So this equation is not too easy to work with. But when I come over here, I notice that there's a variable isolated, and that's x. Even if the x wasn't isolated and it was over on the other side, or the 19 was over with it, in front of x is a 1, since I don't see a variable, since I don't see a coefficient here. I know there's a 1 in front of x. So either the variable needs to be isolated or there needs to be a 1 in front of one of the variables. And what substitution is you identify, in this example, I know that x equals 3y plus 19. Now, I'm used to seeing things like x equals 5 or x equals 6, but in this case, x equals in two terms, a 3y and a 19. And what you can do is, I always circle it, and I draw an arrow to the other equation where the x is, next to the -3. And I am going to substitute or replace, instead of writing -3, instead of writing -3x, I know that x equals 3y plus 19, and I'm able to replace it. And now when I look at this equation, although there's work to do, I only see the variable y. At this point in math, we can only solve an equation when there is one variable. Before, when I looked at both equations, I had x's and y's, but by using substitution and substituting in one of the variables that I know what it happens to be, I'm able to now solve for y. So in this example, I'm going to distribute the -3 to remove the parentheses. I get -9y minus 57 plus 4y equals -32. I am then able to combine like terms. -9 and +4 is -5y. I can move the 57 over to the right-hand side. I get -5y equals, what is that, 25. I can divide by -5, and I now know that y is -5. Remember, the solution to a system is a point, and a point is made up of an x and a y. So I now know that I have a point, and the point has a y value of -5. I do still need that x value because remember, a system of equation is an example where two lines cross, and two lines cross at a point, which means you need an x and a y. So once you find one of the variables, in this case we know what y is, you can go back to one of the original two equations given and plug it in. It is personally easier to plug it into the one that's circled if you have one that's circled. I rewrote the equation that's circled, and instead of putting a y here, I put a -5 because I know what y happens to be. I'm going to do this up above. I end up with -15 plus 19, and I now know that x is 4. I jump down here to my point, and I know that these two lines cross at the point for -5. And that is the solution to my system. Now, what would happen if one of the variables wasn't isolated? So I'm going to do one more example here using substitution. I'm just looking to find one. Give me 1 second. All right. This is a second example. And I'm going to put the two equations next to each other. In ALEKS, they will be stacked on top of each other. I'm trying to save a step of writing here, so I'm putting them next to each other. always triple check that you're copying them correctly. It's really easy to make a sign mistake. Now when I look over here, I see a 4 and a 3. This equation, not much I can do with it. When I look over here, I see a 1 and a negative 2. Perfect, because even though there's not a variable alone in either of these, there's a 1 right here in front of the x. So my job is to get x alone. If I can get the x with the 1 isolated, I can use substitution. I am going to add 2y to both sides. And I now know that x equals 7 plus 2y, or you could write it as 2y plus 7, same thing. Now that x is by itself, I'm going to use the second one here. The 2. Well, actually, Alex uses this first one, so it doesn't even matter. I'll use the first one. Now that I know what x is, I'm going to circle it and draw my arrow over to the x so that I know where I'm replacing. If this was y equals, I would have drawn the arrow to the y, but it happens to be another problem where we have x equals. I am going to rewrite this equation. But instead of putting x in the parentheses, I know what x happens to be. X happens to be 7 plus 2y. So I am able to substitute, hence the name, into the equation that I did not change, what I know x happens to be. I'm going to distribute. I get 28 plus 8y plus 3y equals negative 5. I end up with 28 plus 11y equals negative 5. I can subtract 28 on both sides. Here is one of the chapters where I say you have to be really good at solving equations because it's not something I can keep revisiting. I end up with negative 33 here. And if I divide, I now know that y is negative 3. I'm going to put a square around that. That's half my answer. Now that I know that y is negative 3, I would come back up to the circled equation. It technically is an example of one of the originals. I just rearranged it a bit. I am going to plug negative 3 into what is circled. So x equals, I rewrote it, putting the negative 3. Remember, according to PEMDAS, you have to multiply before you can add. So it becomes 7 minus 6. X equals 1. And it is a point of intersection. So the two lines cross at the point 1, negative 3. X always goes first and y always goes second. And again, even though I'm not graphing this here, we graphed in a previous video. Oops, I should have actually done this for real. This is not a real image. I actually messed it up anyways. Ignore this line right here. This one. If I had a line here and here, they cross at 1, negative 3. That's what the solution means. Again, this is not an actual diagram, but what the 1, negative 3 in this example, if I were to graph the two lines, even though they may not look like this, they would cross at this location. So the solution of a system is where the two lines cross, if they do cross. So I hope that helps with substitution. I will be back with a video on elimination.